Okay, the second method that I want to introduce to you is to use reflections, since we mentioned about the word vertex from our first method. And if we can find a vertex, I mean we can find a mirror line, and we can just reflect our original function through this mirror line. So the idea is to find the mirror line first by using our vertex. Then we sketch the linear functions. Now keep in mind, if we remove those absolute value symbols, we have linear functions. So we will sketch these linear functions first, and we will keep our right hand side part of that linear functions because it's identical, and then we will just reflect that part over our mirror line. Okay, so let's go over our example again using the second method. So first example, to find a vertex, again reminder, make whatever inside that absolute values symbol become 0. So in this case x is 0, so x equal to 0 become our mirror line. Okay, then we sketch our linear function. So removing these absolute value symbol, we have the linear function y equal x. So that's why we have the graph of linear function y equal x over here. And for our absolute value function, we will keep the right hand side part from the mirror line. So this is our mirror line, that's the right hand side. So we keep the right hand side because it's identical to our original function. And then with the left hand side, we can just ignore the linear graph of that part. And then we reflect this right hand side part over that mirror line. And we will have the graph of the absolute value functions. And if you see, you can tell that it's exactly the same as the graph that we drawn using the table value. Okay, example 2. Let's find our mirror line, so our vertex. So make the expressions inside the absolute value become 0. So if x plus 1 is 0, then x has to be negative 1. And x is negative 1 will be our mirror line. So keep in mind, this is not the asymptote. I'm using the broken line to indicate the mirror line, not the asymptote. Okay. Second step, we draw the linear function. So remove these absolute value symbols. We have the linear function y equal x plus 1, which is the straight line that with gradient 1, y-intercept at 1. So that is our linear graph. Alright, so our mirror line here will split the graph into left hand side and the right hand side part. We will keep the right hand side. Okay. We ignore the left hand side now, so this is not needed now, and we will just reflect this line over the mirror line. So let's choose the point easier. If I have a point here, that will be over here, and connecting them, we now have the graph of these absolute value functions. And again, it's exactly the same as the graph that we drawn using the first method, table value. Okay. All right, the third example. So to find our vertex, make the expression inside the absolute value only, not the entire part. So only the one that inside the absolute value symbol. So in this case, it's x. So x is 0. So our mirror line will be our y-axis. So x is 0 is our mirror line. Okay. Then we sketch the linear graph. Y equal x plus 1. So remove the absolute value symbol. We have y equal x plus 1, which is the straight line that goes through y-intercept. Y-intercept equal 1. Alright, so we have our mirror line. We have the linear graph. Now we keep the right hand side part and ignore the left hand side part, and reflect the right hand side part over the mirror line. So let's choose some point, is it easier. So mirror distance will remain the same. So this distance here will be the same as this distance here. And we have our absolute value functions exactly the same as if we use the table value. Okay. Next time I want you to check is to have a look at these two, example 2 and 3. See where the absolute value is and see how different they are. Okay.